Hello friends, Mr. Burrell here. We're in Unit 4, the second unit on polynomial functions. We just talked about factoring. We spent a couple videos talking about factoring quadratic expressions. Now we're going to talk about the quadratic formula and square roots. So this should be a little bit of a review from Math 2 last year. But again, we're going to talk about the quadratic formula and square roots and how we use them in relation to solving polynomial functions, specifically solving quadratic functions. So objectives, this is what I want you to be able to do by the end of this video. Know the quadratic formula, solve quadratic equations using the quadratic formula, and solve quadratic equations using square roots. Those are each of the things that I want you to be able to do after this video. Again, these are things that you already have learned, but this will be a little bit of a review, probably a lot of review for some of you. So this right here is the quadratic formula. So when it comes to quadratic equations, when it comes down to it, what we're really concerned with is solving quadratic equations using the zero product property when we're factoring to solve quadratic equations. But in the real world, what we're concerned with when we're looking at quadratic equations is solving them. But a lot of times in the real world, those quadratic equations are kind of nasty. They can't always be solved using our factoring methods or some of the other methods that we've talked about for solving quadratic functions. So the quadratic formula is kind of a save-all. It can solve all quadratic equations, even those with complex solutions and other quadratic functions that cannot be factored. No matter what the quadratic equation, this formula will be able to solve it. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that comes from a quadratic function in standard form. So when I have a quadratic function in standard form, it looks like this. ax squared plus bx plus c equals 0. So when I have a function like this that's set equal to 0, and it's in standard form, meaning the x squared is first, then the x, and then my constant or my number, the coefficients or the numbers in front of each of those terms, represented by a, b, and c, I just plug into this equation in place of a, b, and c. If you're curious as to where this formula comes from, how it's derived, please let me know. I would love to show you. We don't have time to cover it in class or in this video, but I would love to show you sometime. So here's an example. 4x squared plus 12x minus 7 equals 0. This is an example of a problem that actually probably could be solved using factoring, but we're going to show here that it can be solved using the quadratic formula. So I have 4x squared plus 12x minus 7 equals 0. I'm already in standard form. ax squared plus bx plus c equals 0. So let's identify what my a, b, and c values are. A here is going to be 4. B here is going to be, B here is going to be a positive 12. And C here is going to be negative 7. So my A, B, and C values are 4, 12, and negative 7. So here is my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You don't need to memorize that. I'll give it to you. But that's a quadratic formula. So if I want to know the solution to this quadratic equation here, the solution or my zeros or where my x-intercepts would be, I'm going to go ahead and plug each of these values into the quadratic formula. So I have negative, and I'm going to go ahead and write out the quadratic formula like this real quick. So I'm going to write each of these values. You notice I'm just leaving a bunch of open parentheses here. So if you were to plug this in your calculator or something like that, or into Desmos or somewhere, it would be very critical that each of these values, each of the places where I put parentheses, you also put parentheses. Otherwise, sometimes the negatives and the multiplication kind of gets thrown off. So here in the place of b, I'm going to put 12, because that's the value of b. Here I'm going to put 12, so b squared minus 4 times a times c. So these are both b values times a times c. A is 4, c is negative 7. All divided by 2a, which was 4. Okay, so there's a lot going on there. There's a lot of numbers in there. Let's simplify a little bit. Let's get rid of some of these parentheses. So if I'm going to simplify this a little bit, negative 12, well, I don't need that parentheses for that. That's just negative 12. Plus or minus the square root of 12 squared is 144. That's 12 times 12. Let me double check in my handy dandy calculator. Yes, 12 times 12 is 144. Minus, and then I have all of this jazz here. So I have a negative 4 times negative 7. So a lot of us will be tempted to do this subtraction here first, but remember the order of operation says I need to take care of all this multiplication. So negative 4 times negative 7, negative 4 times negative 7 is a positive 112. So I did this math problem right here, and then I did this math problem right here, and in a minute, I'm going to add them together. So that's all divided by 2a, or 2 times 4, which is 8. Okay, well, I can simplify this. What's 144 plus 112? I'll do that in my handy-dandy calculator. 144 plus 112. I have negative 12 plus or minus the square root of, that's 256. All divided by 8. Negative 12 plus or minus the square root of 256 divided by 8. Okay, now in my calculator, I'm going to take the square root of 256. So let me go down here. I get negative 12 plus or minus the square root of 256 was 16. So I have negative 12 plus 16 all over 8. Okay, I'm about as simplified as I can go to this point. This square root came out really, really nicely. It won't always come out that way, but sometimes it will. So now, remember, in a quadratic equation, I'm going to have 2 solutions. This 2 right here tells me I'm going to have 2 solutions. And those solutions are going to be negative 12 plus 16 over 8 and negative 12 minus 16 over 8. That's what this plus or minus here means, is I'm going to have 2 different answers, 2 different solutions. So negative 12 plus 16, in my calculator I'm going to do negative 12 plus 16, and I get negative 4. And then I'm going to divide that by 8. Negative 4 divided by 8 gives me 0.5. So my first solution is 0.5, or 1/2. See that? Look okay. So next on the bottom here, I have negative 12 minus 16. I enter that. Negative 12 minus 16 is negative 28. And then divide that by 8. I get, and I'm doing all this in my calculator, negative 3.5. So my solutions there are 0.5 and negative 3.5. Those are my 2 zeros, or my 2 solutions, 0.5 or negative 3.5. And that's it. I'm done. You can check that off the bucket list right there. Those are my 2 solutions. Okay, let's go on and do another example. I have 2x squared plus 1 equals 2x. So in this situation, in this problem, it's not in standard form yet. I need it to look like this. ax squared plus bx plus c equals 0. So I need it all to be equal to 0. I need all of my terms on one side. In this case, it's not like that yet. So I first, before I do anything, have to get it in standard form. So I have everything but my 2x on this side. I have 2x squared plus 1. So on this side, I'm going to go ahead and subtract 2x on both sides, because 2x minus 2x, that'll give me 0 on this side. And on this side, I'll have 2x squared minus 2x plus 1. That's my standard form there. Okay, I'm in standard form. Now I want to identify my a, b, and c values. A, b, and c values. Well, here's my a value, here's my b value, and here's my c value. So a is 2, b is negative 2, c is 1. So I'm going to go ahead and plug all those numbers. I'm going to erase this for a second. rewrite it up here. 2x squared minus 2x plus 1 equals 0. I'm going to plug all of these values into my quadratic formula. X equals negative b plus or minus the square root of b squared, there's another b, minus 4 times a times c, all divided by 2a. And I'm going to put all those numbers in parentheses here. So my a value is 2, so I'm going to put a 2 here and here. My b value is negative 2, so I'm going to put a negative 2 here and here. And my c value is 1, so I'm going to put a 1 here. So now I'm going to simplify. I'm going to try to get rid of some of these parentheses. So negative of a negative 2, that's a positive 2, or just a 2, plus or minus the square root, and then negative 2 squared, negative 2 times negative 2 is a positive 4. And then here on this side of the minus sign, I have negative 4 times 2 times 1, which is negative 8. Ooh, this is going to be exciting. 4 minus 8, and then down here I have 2 times 2, which is 4. Okay, well, let's simplify underneath the square root here. I have 2 plus or minus the square root of, and then I have 4 minus 8, which is negative 4, all over 4. Okay, now we are presented with kind of a dilemma here, because I have right here, I have the square root of negative 4. Well, shoot, the square root of a negative number is imaginary, so I must not be able to finish this problem. Alas, no. Remember, we've talked about that it is okay to have imaginary solutions. In fact, it's pretty common to have imaginary solutions. So, what do I do with this? What am I going to do with this? Well, if I have 2 plus or minus the square root of negative 4, all divided by 4, this is what I'm going to do. So, I know that the square root of a negative number is an imaginary. So, or an imaginary number, sorry. So, underneath the square root here, this is really 2 plus or minus the square root of 4 times negative 1, all over 4. So, this underneath the square root, I have negative 4, which is 4 times negative 1. Well, the square root of a negative 1, the square root of negative 1 can come out as an imaginary number, or an I. So this negative 1 just goes away and comes out of the square root as an I, which leaves my final answer as 2 plus or minus I times the square root of 4 all over 4. Well, can I simplify that any more? Yes, indeed, I can. I can go a little bit farther if I need to. The square root of 4 I can write as the square root of 2 times 2. If I reflect back on my number prison that I learned in Math 2, I know that it takes 2 of these terms to escape, but only one of them gets out. So 2 plus or minus I square root of 4, the square root of 4 is 2, so I have 2 plus or minus 2I over 4. And if I wanted to simplify it a little bit further, I'd be satisfied with this answer. If you wanted to simplify it a little bit further, I can find the greatest common factor between these two terms, which is a 2, and I'm left with 1 plus or minus 1i over 4, and then this 2 and 4 can cancel out to leave me with 1 plus or minus I over 2. So at any stage here, I would take this answer, I would take this answer, I would probably even take this answer. On a quiz, you'd probably see it closer towards this answer. Like on the ACT, it would look closer to this answer. And you can just leave it like that in this plus or minus format. That's going to be two complex solutions to this problem here. Okay, we're going to skip over this part for now. If you are curious and want some extra help on simplifying a radical and simplifying a quadratic equation, the answers to these quadratic formula problems using this method, please let me know and I can reach out to you. The last method we're going to discuss is the square root method. Again, this is something that you've already learned. So when I have a quadratic equation like this, ax squared plus bx plus c equals 0, and this term right here, the middle term, is missing, so I just have ax squared plus c equals 0, I don't need to use the quadratic formula. I can just use what I know about square roots. So right here, in these two examples, you'll notice I have my x squared term and I have my constant term, or my x squared and my number term. So I'm going to solve this problem using square roots, and this is how I do that. So if I have x squared minus 64, I'm going to go ahead and add 64 on both sides of the equation. So I have x squared on one side and 64 on the other side. X squared equals 64. Well, since I don't have this other like bx term, I don't have an x term anywhere, I have x squared equal to 64. How I undo squaring something is by square rooting something. So square rooting x squared, that cancels out my squared here, and I'm left with x equals the square root of 64. Well, the square root of 64, if I type that in my handy dandy calculator here, is 8. Wait a minute, Mr. Burrell. Quadratic functions are supposed to have two solutions. You are correct, because the square root of 64 can either be positive 8 or negative 8. Because in reverse, if I were to square both of these, positive 8 squared is equal to 64, and negative 8 squared is equal to 64. So my answer is either 8 or negative 8. And to double check, I could plug that back in here for x to make sure that that actually does work. But notice I didn't need to use factoring. I didn't need to use a quadratic formula. I just had to use what I know about square roots. And I can do the same thing over here. 9x squared plus 16 equals 0. Since I don't have this bx term in the middle here, I can just solve by square rooting. So I'm going to go ahead and subtract 16 on both sides. I'm going to get 9x squared equals negative 16. Well, next I need to go ahead and divide by 9 on both sides so I can get this x by itself. X squared equals negative 16 over 9. Negative 16 divided by 9. And then I need to square root. When I square root this, x squared equals the square root of negative 16 over 9. The square root and the square cancel out, and I'm left with x. And the square root of negative 16 over 9, oh, wait a minute. I have the square root of a negative number. Well, remember, that negative is just going to come outside of the square root as an I, right? So if I take that negative out, take care of it with an imaginary number, then I just need to square root 16 divided by 9, which gives me 1.333333. If you write it as a decimal, or if you wrote it as a fraction, that would be 4/3 I. And I would take either of those solutions there. 1.33 I or 4/3 I. And remember that these solutions are going to have a positive and a negative answer, because when I square root something, I get a positive and a negative result. So that's using the square root method to solve a quadratic equation. And that's it. Again, most of that should have been review, but at the end of this lesson, I hope that you know the quadratic formula, that you can solve quadratic equations using the quadratic formula, and that you can solve quadratic equations using square roots. So that's how we solve quadratic equations. As we go on into our next lessons, we're going to start talking about polynomial functions that are bigger than that are not only to a degree of 2, like these quadratic functions, but might be to a degree of 3 or a degree of 4, etc., etc. We're going to expand what we know about simplifying, factoring, and solving polynomial functions beyond just the quadratic into the beyond here. Okay, so I hope that was helpful. Please let me know if you have any questions, and I hope that you enjoyed that as much as I did.